My name is Thomas Deun. I'm a research engineer at the IMT Optics department. Yeah, so I'm working on the multi-photon polymerization and designing of the machine in order to achieve higher plot rates and be able to reach new applications in new industries. I think it's quite a fascinating topic. I mean, in terms of a scientific point of view, because it's working with light and matter at such a small scale is very interesting and beautiful in a way. So right now there are some machines that are using two photon polymerization, but they basically have one single beam. And so if you want to fabricate something, it takes hours or days or even more. So we want to be able to fabricate small features and meta surfaces much quicker. And the strategy for that is to parallelize the fabrication by using diffractive optical elements. So we can divide one single beam into several hundreds or thousands of beams. By the end of the project, we hope to be able to work on meta surfaces that are designed for the visible wavelengths. So this means we are targeting very small features in terms of resolution, smaller than the 100 nanometers, and to be able to fabricate these structures such as meta lenses, but on in few seconds or minutes instead of hours. That's one of the main achievements so far, to be able to parallelize with hundreds of beams. And also, we've worked quite a lot on the autofocus system, because it's quite a challenge when we want to achieve such resolution and precision. You need to detect very accurately the surface substrate on which you're working. And so that was one of the technical and scientific challenge. And I think we are made very good progress on this to be able to achieve greater precision and repeatability. I think we are exploring new ways of fabricating metal surfaces that are not been explored so much, or not to the same scale in terms of numbers of beam that we are making. So it's we are trying new avenues and hope it will open new possibilities. I think that's one of the most nice things in the project is when we see each other. I mean, in real life, every 6 months, every time we come back at the lab with new ideas. We have learned so much thanks to our partners, and our fabrication methods have evolved so much in the last 2 years, thanks to all the learnings from our partners in this project. Yeah, I think such a European project illustrates the power of collaboration. So I think that's one thing that struck me the most is how you can go much further when you just collaborate with others and benefit from the experience and specificities of all those partners. So I think that's maybe the biggest lesson, is the power of collaboration. Yeah, I think for now the main focus for me was to design the machine that have better possibilities, I mean, and properties in terms of resolution and plot rates. But I think the next step after that, when we have reached our goals, is to explore all of those applications in biology and in the industry. I would suggest him to give it a try. And I mean, that's a very hot topic and beautiful, because there are so many people interested in it in the world. So it's every day there are new things to be learned on this topic. So and you have a good combination of practice and theory. So yeah, in terms of scientific and technical skills that are required, I think it's a very good combination of capabilities to be developed, and so it's very nice area.